Hello everyone. Now in this session we will know about the next concept, that one is parallel databases. Under that we will know about the speed up and scale up concept and the next architecture of parallel databases. Now the parallel systems, that one is useful. Now the parallel system, we will know about what exact the parallel system means. The parallel system improve the processing and the input output speed by using multiple processor and disk in parallel. Definitely, if we take a simple example, we have the one processor and one disk, and we apply some work to the particular configuration. It gives a specific output, right? If we provide a two processor, or it may be a more processor as compared to the one, and the more disk to the for the task, definitely this configuration which one is gives a better output. Now the particular there are the two main measures of performance. If we provide a single processor with a single disk, then what will be the performance? If we provide a multiple processor and multiple disk, then what will be the performance? This performance which one is evaluated with the 2 points, that one is the throughput of a system and the response time of a system. Now what exact the throughput? The number of tasks that can be completed in a given time of interval. For example, this configuration completed the 10 task in a 1 minute, and this process completed the 10 task into the 10 minute, right? 10 minute. Now the throughput, the number of tasks that can be completed in a given time interval. This 1 minute completed the 10 tasks, and this 1 minute completed the one task, we can say that. This is called the throughput of the particular system. Then response time, the amount of time it takes to complete a single task from the time it is submitted. That one is a response time. If we submit the one task to this, it completed with the 10 second, and this configuration complete that task with a 20 second. Now that calls the response time of a system. The system that process a large number of small transaction can improve throughput by processing many transactions in a parallel. System that processes a large number of small transactions can improve the throughput. Means particular if we provide the small task, that is the small task, the system that processes a large number of small transactions can improve the throughput by processing a many transactions in a parallel. That is a concept. System that process large transaction can improve the response time as well as the throughput by performing the subtask of each transaction in parallel. These are the two scenarios, which one is showing the throughput and response time. Now the next points related to the system, that one is the speed up and the scale up. Speed up, two important issue in studying a parallelism are the speed up and scale up. Means the particular system speed up the process and also the scale up it. Means it with a minimum time it gives a maximum output. That is the speed up scale up process. Now running a given task in a less time by increasing the degree of parallelism is called speed up. Means one task which one is run that task execute with providing the parallel resources, more parallel resources, and it completed with the less time. That is speed up the process. For example, if we give the one task to one person, it's better we give that one task to a 10 person. That's called the parallelism. and it definitely speed up the process. Now the handling the large task by increasing degree of parallelism is called the scale up. Handling the large task by increasing the degree of parallelism means, for example, that one task assigned to the one person and the one task assigned to the 10 person, that means the speed up the process, and again we assign the one task to the more than 10 people, right? Increase the degree of parallelism is called the scale up the process, right? This is simply the speed up and scale up under the parallelism. Now we will go with the some mathematical term to understand the system, right? That is speed up with increasing the resources. Definitely we increase the resource, it increase the speed, right? Now we increase the resources, definitely it increase the speed. That type of a scenario called the linear speed up, right? Now it's simply the just to maintain the resources and that speed, which one is again the not that much as compared to the resources. That one is a sublinear speed. That one is linear parallel system is said to demonstrate linear speed if the speed up is n when the large system has an n time. We need to know about some mathematics. That one is TL is the large machine execution time. TL is a large machine execution time, and the TS is the small machine execution time. The speed up due to parallelism is defined. That one is a small machine execution time divided by large machine execution time. That one is, we can say that the speed up the process with a particular calculation. Now the parallel system is said to demonstrate the linear speed. Linear speed. If the speed up is n when the large system has n times the resources, means we can say that the speed up is n, means n times speed up the process, then we need to provide the n time resources to the system as compared to the smaller system, right? Resources of the smaller system. That is called the linear speed. Now if the speed up is less than n, the system is said to demonstrate the sublinear. Means if with the help of the same scenario but the speed is less as compared to the given resources, then that speed up is called as a sublinear speed up, right? Then the next, that one is scale up with increasing the problem size and resources. Scale up related to the ability to process large tasks in the same amount of time by providing the more resources. Means a scale up with us within a 1 minute we just complete the large task as compared to the small task. Let q be the task and the qn be the task that is in n time bigger than the q. Q is the one task and the qn is a bigger task, n time a bigger task than the q. Suppose the execution time of q is on a given machine is a ts, right? And the execution time of a qn on the parallel machine is a ml, right? That one is a tl. We can say that the parallel machine, that one is a large, ts means the small. The scale up is then defined as a ts divided by tl, right? Is a small machine task, or it may be the execution time, we can say that, and this large machine execution time. The scale up is then defined as a ts divided by tl. The parallelism system ml is said to demonstrate linear scale up on the task q if tl is equal to ts. That one is a execution time of the small machine is equal to execution time of a large machine is equal, then that scenario we can say that the linear scale up. Alright, that one is this line. The TS and TL is the same. Alright, means it's a constant linear speed. Now the linear scale up the process. If the TL is greater than the TS, the system is said to be demonstrate the sublinear, because of the when we assign the task to the small machine, it execute with the less time, and when we assign the task to the large machine, the execution time is again the more than the smaller machine. That's called the sublinear scale up process. Means degrading the process, we are scale upping the process. Now there are the two kind of a scale up that are relevant to the parallel database system, depending on how the size of the task is measured. Now the particular two type kind of scale upping. The batch scale up, if we think about the scale up definition, scale up is handling a large task by increasing the degree of parallelism. Means we have a large task and we provide some more resources, or increase the degree of parallelism. Means definitely we need to increase the resources. That's called scale up the process. Now the scale up have two types. Is a batch scale up. The size of the, we will go with this theory with some notes. That means two kind of a scale up. Batch scale up, size of the database increases and the tasks are large jobs whose runtime depend on the size of database. Okay, tasks are large jobs, then that one is a runtime depend on the size of databases. Size of database measures of the size of the problem. That one is simply the batch scale up. Okay, it's depend on the task, work task. Now the transaction scale up rate, means this one is just batch scale up, means it's depend on the size of database, we can say that. And transaction scale up, it's depend on the transaction speed or the transaction count, right, on the database. That is the scale up process about to batch and the transaction. Now the transaction rate at which transactions are submitted to the database increasing, and the size of database increasing proportionally to the transaction rate. For example, if we withdraw or the deposit the money from the account and the growth rate of that transactions, deposit and withdrawal is increases, then what is the solution? Solution is parallel execution, concurrent and the independent on a separate processor. That is the solution, and which one is scale up the process. That is the transaction scale. Now startup cost of the given process, that one is associated with the initial single processor. Parallel operation consists of thousands processor. Startup time may be a overshadow the actual processing time. That one is affecting the speed up. Definitely parallelism gives the proper output. Now that one is depend on the startup cost is depend on the scenario about is about to a single process or the multi-process. Now the interference in a parallel system uses shared resources. A slowdown may result from every new processes. System bus, disk, lock, both speed up and scale up are affected. Means if we share the resources, then the both point is affected, that is the scale up and the speed up.